All right, so at this stage, we've drawn our first graph. We've identified a square. Oh, sugar. I just realized that I didn't put a square root on that. So we've identified a square root relationship based on the shape of the graph. And so that tells us that we need to square root our values for independent variable. So our column here is going to be the square root of change in height. And because we square root the change in height, it means that the units are square root of whatever we used before, which in this case is centimeters. Okay. And our values there, so keying into a calculator, will give us 4.36, 3.74, 3.46, 2.83, and 1.41. And just to be clear, we are square rooting the change in height. We need to be careful not to square root the average time, as I've been known to in the past. Okay. So double checking that everything's right there. We're now going to do a second graph where we plot the change in height, the square root of change in height, as our independent variable on the x-axis against our times. Now, at level 3, we're going to do something a bit different in that we're not using the average time here. We're going to plot all of the times, and that is going to give us a range, and that allows us to show our uncertainty. So more on that as I could do the graph. So those are the values we're using. As before, we've got a bit of graph paper ready, and let's label up our axes. So this axis down here is now the square root of the change in height. I can do it in symbols or I can do it in words. So I could write out square root of change in height. I'm just doing it this way because it's less writing. And I put my units on there as well, which is square root of centimeters. Up here, I'm not writing average time, I'm writing times in seconds. The maximum value for time we need, again, is 46.5. Okay? And so I'm probably, even though I'm not entirely happy about it, going to use the same scale as we did for the previous graph. So the time scale is going to be the same. But our change in height scale, our square root of change in height, is only needs to go up to 4.36. So I'm probably going to try and work it out so that it goes up to about 4.5 or 5. So thinking about that, we've got 22 boxes along this way. That is actually going to work out to go to 4.4 and use as much of the graph paper as possible. Okay. So I'm going to go ahead and do that, which means that we are every 5 big boxes is 1 as an increment of 1. Okay, so there's my 5, that's 1, then another 5, and that's 2, and then another 5, and that's 3, and then another 5, and that's 4, which means that 4.4 is going to be that last line there. And because we need 4.36, that is going to use as much of this axis as possible. On the time scale, then we have, I'm going to skip out the 5s, I'm just going to go 10, 20, 30, 40, 50, okay, and we're ready to go there. It's possible that I could have done a better job of these if I had rotated my paper that way and then planned to use those scales for each of the different axes instead. So having more space for time and having slightly less space there for the independent variable or the square root of change in height. So we're ready to plot some points now, and starting off at the lowest value for the square root of change in height, we've got 1.41, and we're going to be plotting 2 time values there because we ignored this outlier. I'm actually a bit regretful because having that extra one in there that was a bit further apart would have shown us the spread of those times, and would have helped us out a little bit more later on. So in this case, being too precise can make your graph a little bit more restricted. So we've got 1.41 and 9.66. So 1.41 is near as damn at 1.4, which is here, and that is going up to 9.66 and 9.78. So I've got 9.66 and 9.78. Okay, and I feel like I've maybe not done that justice. They're almost on top of each other on the graph, but that gives us our 2 times plotted there. Next one is 2.83, and we've got times around the 26 seconds. So finding 2.8, I'm not going to worry too much about the 2.83. Oh, well, should we? In actual fact, I think that would probably be unfair if we didn't. We've got, so just to remind you what's going on this scale, we've got 2, then 2.2, 2.4, 2.6, 2.8, and 3. That means that each little box is going to be 0.04. Okay? Because when we go from 2.8 to 3 in 5 jumps, that's going to take 5 lots of 0.04 to get from the 2.8 to the 3. So it would be 2.84, 2.88, 2.92, 2.96, and 3. So because my value there is 2.83, it's actually going to be closer to this little line rather than that main line of 2.8. So 26.04, so I'm going up from there to 26, and 0.4 is going to be almost right on, will be right on that line basically. We've then got 26.68, so I'm going up 26, and it's going to be about there, and 26.59. I'm not going to write that one in because it's between the other two, and it's just going to make more of a scribble there. It's not going to be clearly visible. Next up, we've got 3.46 as our square root of change in height, and our times are in the 34s. So I'm going to find 3.46, which is going to be just here. So that's 3.2, 3.4, then 3.44, and 3.48. So it's halfway between these two little lines here. 34.65 takes us about here. And then 34.72, so pretty much in the same place. And then 34.37, I can come down a little bit lower for that one. But you can see that these points are really close together. Next one is 4, and that's nicely laid out for us, and we're going up to 42. And 42.03, I'm going to put it right on the 42. Then 42.31 and 42.28. So I'm not going to plot the 42.28, but I am going to try and plot that 42.31, which is just a little bit higher than the other one. Okay, I'm not really happy about how close those are together. It's not very visible. Finally, we've got 4.36, which is this little line right before the end, and we've got 46 in terms of the time, and then 46.5 and 46.3. So again, I'm not going to plot the 46.3. Okay, I'm really struggling here to separate out those data points, but because we've started, we'll finish this example so that you can see what's going on. All right, at that stage, we are ready to draw our lines of best fit.